Good afternoon, everyone. My name is Priya Natarajan. I'm the current director of the Frankie program in Science and the Humanities at Yale. It is with deep sadness that I would like to share with you all the terrible news of the passing of Richard Frankie. Rich was one of the founding duo, along with Barbara Frankie, who has kindly joined us today, of this flagship interdisciplinary program, the Frankie Program in Science and the Humanities at Yale. Today, we mourn the passing of a family member, a kind, generous, and wise elder who guided many of us. To me personally, he was an inveterate cheerleader, keeping track of my research work in science, in astrophysics, sending congratulatory notes whenever he read about my work. We would meet up over coffee and he would pepper me with really hard science questions. You know, he really was a space nerd and had an incredibly curious mind and was so widely read and knowledgeable that it was just incredible how he spanned all these worlds: academia, the creative arts, the business world, politics, and philanthropy. Both he and Barbara remain strong supporters of all our activities, and I have very fond pre-pandemic memories of all of us, the Frankie family, along with the young interdisciplinary scholars, our undergrads, grads, and postdocs, getting together over dinner, discussing bold new ideas to explore and study. He paid attention to all the talks, asked incisive questions, and felt very proud of the young people whose intellectual adventures were not limited by academic silos or disciplinary boundaries. I'm at a loss for words. Let me quote from a beautiful poem by the Lebanese American poet Khalil Gibran, in which the book from the Prophet, in which it's a conversation between the Prophet and a human being. You would know the secret of death, but how shall you find it unless you seek it in the heart of life? The owl whose night-bound eyes are blind unto the day cannot unveil the mystery of light. If you would indeed behold a spirit of death, open your heart wide unto the body of life. For life and death are one, even as the river and the sea are one. So let's have a moment of silence in his memory to remember him as he was, deeply empathetic and a beautiful human being, always smiling, energetic, and brimming with curiosity to forever learn. Barbara, we mourn with you and the rest of your family today, and we wish you strength and courage at this extremely difficult time. You are both an inspiration to us all. So let's have a moment of silence before we start today's program. Let's begin by recognizing our benefactors, Mr. and Mrs. Richard and Barbara Frankie, acknowledging the sad loss of Mr. Frankie last Friday. Today's talk is one that we have all been looking forward to with great excitement. And it is with great pride and pleasure that I introduce our speaker, one of our own Frankie Fellows, who started this wonderful project, cross-disciplinary project, and despite many personal challenges, health challenges, has emerged victorious, enthusiastic, and super productive in terms of his work. So the talk today is by Diego Ellis Soto, and the title is Collective Pulse, Uncovering the Hidden Lives of Animals Through Music Theory and Artificial Intelligence. I can tell you all that you're in for a treat this afternoon. First, let me remind you that we are recording this event, and therefore all participants will have to have their videos muted for the duration of the talk. Questions may be submitted at any time in the Q&A feature. So let me introduce our young and brilliant scholar, Diego. Diego is an Uruguayan biologist studying how biodiversity across the world responds to current and future climatic conditions in a rapidly warming world. Work, as you all know, is extremely urgent and timely. He tests ecological theory using cutting-edge technologies, animal GPS collar data, drone imagery, citizen science data, satellite imagery, statistical modeling for applied conservation outcomes. He's particularly interested in understanding how, why, when, and where species move at local, regional, and global scales. This is, of course, critical in order to predict the ecological consequences of increased human activities and changing climates on biodiversity. While the bulk of his PhD work involves sitting between a computer screen and a desk chair coding, Diego has performed field work and research on the ecology of giant tortoises in Galapagos Islands for the past 9 years and is passionate about scientific communication as well as his research work. He joined Yale in 2018 and is currently a fourth-year doctoral student in the Department of Ecology and Evolutionary Biology. Besides being a Franke Fellow, one that we are extremely proud of, Diego is also an early career Rufford Conservation Explorer, a Yale Global Food Fellow, a Law, Ethics, and Animal Program Fellow at the Yale Law School, and an Environmental Humanities Student Grant Awardee. He exemplifies the best of what Rich Franke had in mind for a truly interdisciplinary scholar working at the cutting edge, using cutting edge technologies to answer some really old, profound, deep questions. He obtained his undergraduate education in environmental sciences from the University of Trier and his graduate studies in biological sciences at the University of Constance. Shortly afterward, he worked at the Max Planck Institute for Animal Behavior, leveraging large amounts of biological data for hundreds of species across the world. During this time, this is the most enviable part of his CV, he lived in the Galapagos Islands for over a year, working with the giant tortoises, and spent several months in the Ecuadorian Amazon, working with poison frogs. He worked as a DJ throughout his time in Germany and performs music at the interface of natural sounds and electronic music. I mean, I think, his resume is just impossibly filled with sort of these talented things that, he has productively engaged in. I don't know how he has time to do all of this, given how young he is. But there you go. He's also very passionate about scientific communication. And of course, his work, which, as you will see in a moment, just is at the frontier, has been featured in dozens of news outlets, including BBC Nature documentaries, the New York Times, Spanish newspapers, ABC News, Yahoo News, and so on and so forth. In addition, his most recent work researches the impacts of altered human mobility during COVID-19 pandemic on wildlife across the world and has been endorsed by the United Nations. So COVID, as you all know, the global pandemic not only impacted us humans, but the entire natural world. It was traumatic for the entire natural world. Diego aspires to bring the humanities and the natural sciences together, both at work and in his spare time. He performs in electronic music festivals across the globe, and he's increasingly interested in combining electronic music with soundscape ecology using open source technology. We are also delighted today to have Matthew Suttor, professor in the practice of sound design at Yale School of Drama, who will be joining Diego today in his presentation. Professor Suttor has been a leading part of this project alongside Diego since the beginning. We're particularly grateful for his continued support through personally difficult times for Diego. New Zealand-born composer Matthew Suttor has taught at Yale University since 1999, first in the Department of Music and since 2002 at the David Geffen School of Drama. He is also affiliate faculty at the Center for Collaborative Arts and Media at Yale, often combining music technology with acoustic forces. Matthew has composed operas, dance works, and music for all kinds of theatrical productions, chamber music, and sacred sound installations, scores for television, and so on. His work in opera and dance includes Don Juan in Prague in collaboration with the director David Chambers for the Bard Summerscape Festival, and which was revised for the Mozart Prague Festival the Guggenheim Works and Process series, and the BAM Next Wave Festival. He composed Zoom Slides television series Real Pacific and Anna Marbrook's documentary feature film Loy Mata. He has been involved with Yale Rep Theater productions that include The Intelligent Design of Jenny Chow, All's Well That Ends Well, The Winter's Tale, Arcadia, and An Enemy of the People. He's extremely distinguished, a Fulbright scholar, and he received a doctorate in composition from Columbia University. I could spend the entire hour telling you about the wonderful accomplishments of the two scholars today, but without further ado, let me turn it over to Diego. Diego and Matthew, thank you so much for speaking to us today and sharing your ideas.
Thank you so much, Priya, for this kind introduction. Thank you, Ms. Frankie, for letting us dream big with the support. So none of this would have been possible without this initial support from the Frankie Project. And I hope to show how an initial support towards students can snowball into a larger project that is Collective Pulse now. So thank you for believing in us. Today, I'm very excited to present a joint work. I'm extremely flattered to be giving this talk. It's a professional highlight for me. Thank you for the opportunity. This is a large team effort in a truly collaborative manner, as hopefully you will see in the last acknowledgement of my slide, involving people on farms, local hospitals, engineers, musicians, composers, ecologists, conservationists. It's been truly a pleasure and a privilege to be able to work with every single one of these people, and particularly Matthew for the patience, the mentorship, and the expertise, and just the creativity to dream big and take this forward. Today, we will be talking about new ways of exploring the natural world and looking at the hidden lives of animals through a bird's eye view, literally, using new emergent technologies that let us capture the voyages of animals and how they sound like and how they look like, and the danger of what happens if we lose this incredible beauty in the natural world by human activities. And I would like to introduce the main characters of today's band. We have flying pigeons on a piano. We have homing pigeons on a different piano. We have stickleback fish on the drums. And we have 8 termites that decided to make a mixture of electronic music and classic guitar. So the beauty of the natural world knows no limit. Many of us probably have seen these incredibly flocks of tens of thousands of birds flying at once in unison. And this looks incredibly harmonic. And people have wondered for a long time, how do these rules go together? Do they have telepathy? How do tens of thousands of animals organize at unison? And to many people like Matthew, this probably looks like music. And he will expand a little bit more on this. At the same time, how I started, this is me on the left next to my brother. I'm the one with the glasses. As a 5-year-old, I guess I've always liked animals and biology. And on the right side, I sort of always like music. I'm the little one watching my brother jealously playing the flute while my dad is looking at musical sheet. But I always played my cards right. This was outside an airport where we asked adults for money to then buy candy and some dinosaur toys. So I think I've always had a passion for music, getting a lot of different people together to get the most out of a project as a collective, and inspiration of the natural world. I actually started in the humanities. I started as a journalist and then quit and went to Germany to study biology. Little did I know that it would change my life. Fast forward 25 years, I now study animal migrations, particularly across the world, and how they move and how biodiversity is moving under global warming. Here we can see a picture of the globe where every single pink line is an individual animal tracked with a little GPS collar that allows us to monitor the voyages of these animals. And we can see almost that animals are almost like veins or pulses across the world as they are following snow melt in the northern hemisphere. They're going up. And as snow comes back, animals are going down into the southern hemispheres, almost like a collective pulse through the planet. And this is something that I've been investigating in my PhD for a very long time. And in my laboratory at Yale University, led by Walter Yates, we're also very interested in creating tools that allow the public to visualize these voyages of animals and represent the hidden lives of animals, bringing them closer to the public, such as animal lives. But also during the last years, I've been focusing more on music production using a variety of different softwares. On my PhD, I use a lot of different technological advances to improve the way that we can monitor and document biodiversity and how it's changing. For example, on the right side, we have over 900 satellites measuring environmental conditions 24 hours a day that allow us to measure the pulse of the planet in terms of vegetation greenness, as seen on the left. And this is incredibly important and increasingly important because we're currently in the 6th mass extinction. And this is a human man-made catastrophe with human activities driving several species to extinction. And what's even worse is there's many species we don't even know about. And we are losing not just important ecosystem services, but also the incredible beauty of nature, their sounds, the way they look like. And it's really important to document this and better understand the change through time. This is, for example, an article that highlights some scientific communication of my research lab, where through maps, we're able to visualize biodiversity closer to humans. And actually, because of this Frankie project, I've started to think maps are a really, really incredible way of communicating narratives and scientific stories to humans, but music can be the same too. And this is something that we are increasingly able to do. We can document human activities through time, and we're able to understand the impacts of biology on these changes. For example, we can see how urbanization and human activities are changing ecosystems, but also what ecosystems sound like. And by here, I want to say that this is by no way something that we have invented here. There has been many people that have pioneered this work, and I want to highlight two of them, namely Benjamin Patterson, who was an incredible artist and was employed as a classic bassist, but he was denied employment because of his race. And he recently died in 2016, but to my knowledge, he was the first person exploring how to make music with ants. And what Mr. Patterson did, he put a music sheet on the ground and tossed ants on it and followed their movements by drawing on a pen. And here you can see Mr. Patterson trying to make musical sheet out of data of ants. And he later mentioned that, while this is not music or musical, it's a new method of making music. I also want to acknowledge work by Bernie Krause, a soundscape ecologist, and he created the soundtrack of Apocalypse Now. And on the left, we can see Mr. Krause deploying some sensors to look at some microphones to look at habitat change on ecosystems. And on the right, we can see Mr. Krause with one of the first Moog synthesizers, such as Matthew has in the back, to make music. And Mr. Krause also said, a picture is worth 1,000 words, but a soundscape is worth 1,000 pictures. And this is actually incredibly important. And Mr. Krause has recently wrote an incredible book called The Great Animal Opera, with interesting insights as of how humans learned how to dance based on the natural world. And his concept of the animal opera was covered by the Sydney Biennale. And what you can see there are sound waves of the natural world on the orchestra house in the background. So there's increasingly appreciation also in the larger public around the work of documenting soundscapes and documenting biodiversity. And this is incredibly important also as a biologist wearing my global change biology hat, because Mr. Krause's recording from the 60s allows us to document not just how sounds and ecosystems has changed, but whether species are still there or not, and why this might be, and how fragile soundscapes might be due to human activities. So it's an incredibly powerful tool of scientific communication, but also to understand the natural world from a scientific perspective. And what is new here in our project is that we are trying to document and leverage these new incredible technologies that are available to us as scientists, namely animal tracking technologies that let us put a satellite tag on an animal and follow it its entire lifetime, computer vision that allow us to track hundreds of animals simultaneously, as we can see in the middle, termites and fish, up to the right side, where we have smartphone apps that have machine learning algorithms that allow us to identify any bird calling in real time. You're going to see a chickadee, I think, arrive and being recognized almost instantly by these algorithms. So we're able to leverage this incredibly amount of biodiversity data for conservation purposes, ecology, but also to bring this incredibly fragility of the natural world and the incredible beauty closer to the public. And we are not alone here. As I said, there's many people who have thought deeply about this. And Aristotle mentioned, even in his book, De Anima, written 2000 years ago, that every kind of animal should be studied and revealed as it has something incredibly beautiful in the natural world. Well, fast forward 2000 years, now we have really good, powerful AI that allows us to track a lot of different objects, humans and species in incredible detail. And we're able to leverage this for tech, for conservation and for good. As shown here in 2015 by Rosenthal et al., this is a Facebook social network of fish. Here we can see a number of fish, and the graphs and the nodes between them is the relationship that each of these fish has to their neighbor and their local interactions. So we can not just uncover the hidden lives of single animals, but what's even more fascinating is their collective behavior. And incredibly, research in collective behavior has shown that actually very simple rules in nature determine very complex patterns. As seen here, there's 3 different collective states that animals could be in, and these are largely determined by animals don't want to be too far away in groups, don't want to be too close together, and they want to move at a similar speed. And we could think of these 3 different states as being almost universal in nature. Swarming can occur in mosquitoes, it can occur in fish. Polarization, when there's almost a harmonic, very directional movement, is almost like a V formation in fish or a V formation in flying fish. And milling can occur in fish, or if any of you ever wants to Google reindeer cyclone, it's when reindeers move in a circle, very familiar to watch. But what on earth has this to do with music theory and music? Well, this is when I had the pleasure of meeting Matthew right before the COVID-19 pandemic, and we started talking about these things. And it has been an absolute pleasure and privilege to work with him. And I would like to give Matthew the word to explain a little bit more.
Thank you, Diego, and good afternoon, everybody. So, as Diego was just explaining, the basic rules of collective animal behavior, and this is a composer explaining to scientists, which I acknowledge, is that animals want to move in a common average direction, common average speed, and common average distance from each other. Those are the rules of harmony. That's how I teach students how to compose a chorale in the style of Bach. They are the rules that Palestrina used, and they're still the same rules that we use to write pop songs. So if I talk a little bit about the ideas behind it. So when I look at, say, the murmuration of starlings, you saw that one of the video that Diego showed earlier on. I look at that and I think that looks like music. But it's not a trivial thing to work out how to take that 3-dimensional behavior, even if you have really elaborate, exact tracking data, and then map that onto musical parameters. So by musical parameters, I mean pitch, rhythm, duration, articulation, phrasing, timbre, which is tone color, etc. So the first place, or the obvious place that we wanted to explore is that if we have, for example, XY coordinates on a Cartesian plane, tracking individual animals, well, then we could map that to, say, pitch. And in music theory, we talk about pitch space. And in this case, we're looking at what's called a tonets, which is 19th century music theory. This is not new. And you can see that moving left to right, we've got on the horizontal we have perfect fifths, and then on the diagonal we have various kinds of thirds, major and minor thirds. And if you look at the triangulation in the middle, C, E flat, G, that's a C minor triad. And then if you flip underneath C, G, E, that's a C major triad. So there's a way in which you can theoretically navigate around a pitch space and map coordinates to it. We've even started to look at more complex shapes. Here we've got a tonettes in the shape of a torus, which our mathematical friends insist is actually still two-dimensional. I wanted to call it three-dimensional and was quickly disabused of that. So as I mentioned, this is not a trivial thing to work out. Well, how do you make music from this data? So we've had some breakthroughs recently that I'd like to share, just to give you a taste of where we are heading. So here I have the beginnings of taking the data that we have for a group of 10 homing pigeons. And so the data is around 150,000 lines, which includes XY coordinates and also other information to work out whether they're milling, swarming, or they're polarized. And so simply what I've done is we've taken that the Cartesian coordinates, and the breakthrough which actually came, well, how do we visualize this? And through thinking through visualizing it for you, we mapped the Cartesian coordinates to polar coordinates. And then lo and behold, we found a way of mapping that to pitch space. So what I'm going to play here, which is actually going to run in real time, it's not a recording, is taking the data of XY coordinates, turning it into polar coordinates, and then mapping that to a pitch space, and then sending that to another program, which is going to play back choral samples. So now, in theory, we have a choir of 10 pigeons, and to me, it sounds like music, but that may be debatable. But it's a first step. Here we go. So that's the beginning of something that, at least from a compositional point of view, I really do feel that we've got something to work with. So just to show you briefly what it looks like in terms of actual music. So what we were playing then was recorded in real time, and there we have pigeons. Homing pigeons producing chords that, if I were to look at this, I would say this is music. And so I'm pretty excited about the potential for this. The next step, of course, would be to take this and then map the movement onto a surround sound system, so a kind of cinematic experience. It might even extend as far as, say, a virtual reality experience where you could be a pigeon in the flock of pigeons while listening to the realization of this. So we're really excited for this, and something that it was an unexpected thing for me is to look at, say, these recordings of environments that Diego is going to be getting into, and making musical realizations of those. So it's not just the flocking or the schooling data, but actually taking environmental recordings and then mapping that onto musical spaces. So the sonification and visualization of data, which is something that I'm really interested in, is a way of showing people what is happening in the environment. So it's one thing to sort of say, here's what's going on in terms of some kind of abstract description. It's another thing to express it through art. So that's part of the project, and I'm really excited to be working with Diego, and I will hand it back to him. Thank you.
Thank you, Matthew. We are not the first people to talk about data sonifications. NASA has been working on this for quite some time. Here we can see what galaxy sounds like. Different colors are different pitches. But I do believe that one of the major advantages and progresses of this project is that we are applying both musical theory and biological theory, for example, as the tonets that Matthew has mentioned. We are also adding, we've performed, apologies. We're also exploring different ways of playing with chord progressions and feelings. For example, as some of these collective states in which animals can be, such as swarming, or whether they are transitioning from one state to another, these are somewhat more chaotic. Or we can, for example, add different chord progressions to them to evoke emotions as animals change from a more chaotic system, such as swarming, to a polarized state. And in addition, we are exploring new ways of, such as we call it the pigeon reader, what Matthew just showed you, almost of creating new synthetic synthesizer or instruments that artists could use. And the interesting part of this is that this would represent a direct connection of nature with an artist. So it actually really physically matters where the artist is in space and how the output of some of this music might sound like. And I'm going to jump a little bit into some variables of interest that we've been interested as biologists, and I will showcase you 4 different examples of music that was generated by different animals and how this has a little bit evolved in complexity through time as we've learned so much from this project. If we have a group of fish, for example, we could look at a single fish. We could look at how fast are you going? How fast is this fish accelerating? What's the distance between its next fish? We could also look at the collective and say, what's the average speed of the collective? Where is the collective average position? What's the degree of alignment among these fish called polarization? How much are they moving around their own axis, rotation? Is this a collective state that is stable, such as polarized, or are they trying to transition? And I'm going to try to showcase some of these parameters we've been playing around with some pigeons. In this example, we split our pigeon group into 3, and these 3 groups of pigeons represented 3 different notes on a keyboard, and it's going to sound very clunky.
Diego, we are losing the sound somehow. Could you turn it up?
Is this better?
Yes.
So this is a very chaotic, clunky sound as displayed in the art on the bottom left. And I'm excited to say that we currently have an art exhibit opening that's going to display all this art, and we will show you a little bit later a glimpse of it. Our next artists on the ensemble today are Stickleback Fish. And this is an image of these fish in a fish tank. And I showed this to an artist at Sci City, and he was surprised by how beautiful this was. And I said, it was made by the animals themselves. This is their reality. This was their experience in a couple hours in a fish tank. So we are communicating with different artists and sculptors of exploring new ways of representing the natural world through the animal lives themselves. And we have applied the same principle. We have a group of, I think it was 10 fish in a fish tank. We have split this into groups of 3. So if you're close to 2 others, you will become 1 key on a pitch space, as Matthew was explaining. And as the fish moves, the different keys will change. And it's very interesting because you can even listen that these animals are in a different medium. Fish can turn around because they're in water. A pigeon can't just make a full stop and then turn around. So we can even listen the different mediums in which these animals live and experience the world. These are the actual homing pigeon that Matthew was showing you. These were tracked with GPS collars, and every single one. And they're part actually of a seminal paper that discovered leadership in pigeons. Who's leading a flock of pigeons? So we're actually using cutting edge scientific data for this data sonification. This is a previous version of Matthew's pigeon reader. And on the top right, we can see the art. This is the actual tracks and the actual data. So the raw Excel sheet plotted on a landscape. It looks like a artist just made a splash, and every single color is a different individual. And here we're going to see Matthew performing and practicing live at our opening at Sci City earlier this week. It was so much fun. And here we have my personal favorites. These are 8 termites on a Petri dish. And here I want to highlight and showcase how our artificial intelligence computer algorithm works. Namely, it's able to track every single termite. And each different termite is tracked in its position and its time and its unique identity. And what we get out of this is the raw data of a time, a frame, a position in X space, a position in Y space, and the identity. And this is the raw building block for a lot of these musical parameters and collective behavior parameters that we're creating. This means that we can make this for almost any single animal now on. And we have the code, and we are planning to make the code fully available in public in GitHub. We want everyone to be able to use this and claim by no way that we should be the only ones doing this. And in this piece made by 8 different termites, we have an individual termite on I think it was on a guitar, yes. And then we have 3 different parameters, collective behavior parameters of termites translated into music in 3 different pianos. So the only thing I did as a human being was assign different instruments to different parameters of these ants. And besides just computer vision, artificial intelligence, I also mentioned these had credible advantage in sound recognition. And for this, we've put little bird spy microphones in computers, Raspberry Pis, and Audio Moth with $9 microphones from Amazon, the cheapest I could find. And we put them on the Yale farm for a month. And we're planning on keeping them up a little bit longer to document bird migration. And what was incredible is that we detected 60 species at the farm in this 4-week experiment and documented over 20,000 observations. And if you're wondering who was the loudest and most common bird, you guessed right. It was the blue jay, very loud bird, very beautiful bird. And what this AI also allows us to do is it allows us to document the species, but also a confidence of how certain the AI is that it has documented a certain species. So beyond musical interest, this is incredibly exciting for bird biodiversity because we can document biodiversity through time 24 hours a day for under $200. So this could be and is currently a game changer in biodiversity research, especially thinking and communicating about this work with artists, musicians, activists. It has changed the way that I see a little bit my own science, because if we can use all these tools to educate the next generation of scientists, policy makers, and musicians, children. We can empower them to collect and sample and listen to their neighborhoods, learn computer programming on the way, which is a really important skill, learn about the natural world, become stewards of their environment, have a lot of fun doing it, spend time outside, which has been really important during COVID, and make music and art out of it. So this is called STEAM. So it's STEM, humanities, and arts. And I'm thrilled that Sci City gave us the opportunity to open an art display this week in this incredible building, and it's open until Friday morning. So please check it out if you have the time. The building actually looks like a fish tank and a bird nest. And we opened this award, and this was, as a basic scientist, this was my imagination of what this art exhibit could have looked like. I had never done this. And I think we actually came quite close. So I invite you to take a collective plunge with me here. This is the building. Here we have someone exploring the bird spy microphone, trying to play a bird sound and see if it can be documented. To the right side, we have a little poster describing what we found at the farm, who the loudest singer was, who ate the farm compost, scientific communication. In the back, we have the music generated by our 8 termite artists. In addition, as I mentioned, the next generation is all that is what matters the most, because they will follow up with this work. And I'm very proud to say that we launched an art exhibit contest throughout New Haven, asking children of any age to paint any wildlife in Connecticut. And we made flyers both in English and Spanish, and we were overwhelmed by the talent, the incredible imagination of the artists. And here are the winners. We have Lilian Delgado, who documented every single owl in Connecticut. We have Leslie Paulak, a 2nd grader, documenting birds and mammals. And we have Alina Zhang making a 3D chicken. And she sent me several pictures of the process, which is just mind-blowing. And here we have all the other artists. And I have to say that because we made this advertisement in Spanish, we got 40% of emails and submissions that were in Spanish. And the robin was the most common animal drawn. And as a biodiversity scientist, it's interesting that birds and mammals were the most frequent ones being painted by children. And I'm trying to think about a more 10,000-foot view about this whole concept. I love the idea of generating new ways of visualizing the natural world and sonifying it and bringing it back into the hands of the human artists. And this is, for example, how our little microphones in real time can be put into the hands of artists such as Matthew. And I have to say that last week was the first time ever that we practiced music because of the COVID-19 pandemic. Most of this work has been done on Zoom. And it was an absolute pleasure to just brainstorm and code and make music together. We're incredibly lucky to have been supported by artists and cancer survivors of Yale Smilo Hospital. These are origami cranes made by patients in the hospital. And there's a Japanese tradition that if there's 1,000 origami cranes, all your dreams will become true and you will have good health. And I'm very grateful that these incredible art pieces were lent to us. You can see them at the Smilo Hospital. And I love the fact that they're in pride colors. We also got incredibly Smilo rocks that these are the moments that remind me that before a scientist, I'm also a human being. And just reading these just springs my curiosity into a million pieces. And I'm going to read some of them because they're so powerful. Dance to your own music. The birds sing even when it rains. The song of the earth writes the music of my soul. Listen closely. Even the trees exhale their own love songs. Sing the song you were born to sing. Be still and listen. The earth is singing. And these moments are, besides my being a scientist, these moments just bring me back and make me think so much bigger than my scientific research and what the impact could be of this project, also to bring joy to people and promote education and equity in a just way. We also were very lucky to have 3 art pieces by local artists and scientists that are on display on the art gallery. And these are just some of the images. Incredible building. If you have the chance, please go. And this is Matthew and me performing live for the first time ever with the Pigeon Gregorian Choir. Here's a colleague as a collective pulse trying to change the stream of music, and that's totally fine. And this is another fact of so many things that I've learned by working with humanities artists. I invited some of my friends who are dancers to participate, and I said, if you come, you can dance. So they did, and so I did. And this just sprung my creativity to gave me new ideas and make me a better scientist. What if we map all these things into dancers? The last piece of music I will play today is a sneak peek into electronic music production made by the termites, where again, the only parameters that I decided as a human were the instruments they play. And here we have 4 different colors of ants, which just means that I've looked into 4 different patterns of the entire group at once and mapped them into different music space. And to bring this back together, what I've learned through this art exhibit, by collaborating with scientists, artists, musicians, having an incredible team behind us, everything I've shown today is a collective effort. And the most important people are the ones that I will show in my last slide. But every single city can probably do some of what we've shown today. Every city has a school, and we could teach STEAM there. Every city has a little farm or a green space or a vacant lot or an urban garden where we could document biodiversity through food justice and make music out of a farm. I'm excited to make Yale farm music with chicken being hi-hat, shovels being snares, and birds being the melody. A lot of places have hospitals or community centers or universities. So I see this whole presentation of collective pools that we've demonstrated today as a very larger envelope and umbrella of bringing the natural world, technology, art, and humanity closer together, just like the general purpose of the Frankie program as envisioned by Mr. and Mrs. Frankie. And you might be asking what's next. I've learned a lot about working with the humanities in this project. It sprung my creativity, my curiosity. I love the fact that a lot of times artists sit back and let people be and explore, which is a little bit different than how we work in the sciences. I learned about communication being very clear, interdisciplinary work, nonverbal communication, data visualization, emotion, the subjectivity of interpretation, the hard questions our artists ask, and that small grants make us dream big. I've also learned from my dancing friends that this is something I want to do later. Maybe each one of these dancers is a collective. And what if we try to reconstruct through their movement the music that they were singing to? Is that possible? There's going to be so much variation, and each time they dance will be so unique. Maybe we can recreate this. I have no idea, but I'm excited to find out. I'm excited to explore more the sounds of entire ecosystems and how they have changed through time. How do the ecosystems from 1960 sounded of Mr. Krauss versus how they sound now in 2022? And artificial intelligence allows us to split sounds into natural sounds and human sounds, for example, with great ease. So I'm very excited about this. We could make music about every national park in the United States. What does the underwater sound? Also something we'll be tackling. Exploring more musical chord progression with Matthew's mentorship. Working more with the local community in New Haven, which is the biggest excitement of this entire work, was opening my email and seeing artwork from kids, to be honest. That has been the highlight of this project to me personally. And stay tuned because more is coming. We're just getting started. We have another opening on Saturday. We have a climate Bauhaus at the Center for Collaborative Arts and Media. Please come. This is actually art made by Dana Carwas, but this is made out of termite data. It's going to be a large print, so please check it out. And this is the large team that I was talking about that has made everything happen. And please take a second to look at the interdisciplinary nature of these people. We've gone anything from people in a hospital, local community workers, engineers, ecologists, musicians, artists. It's an absolute privilege to work with all of these. And with this, I just want to say thank you all for listening.
Thank you so much, Diego, for that absolutely fantastic, mind-blowing talk. And thank you, Matthew, for helping with the formulation and the sonification of these natural sounds. I'm just so proud that the Frankie program helped you get a start on this absolutely wonderful, really ambitious project, and we wish you the best. And so here's, let's all clap and give you a round of applause. We so wish we could have done this in person as well. But Ty, did you want to take over and handle the questions? I think we have a couple coming.
Absolutely. So just a reminder to the audience to please submit your questions, not in the chat feature, but in the Q&A. And we have one already. So Diego, thank you for a fascinating presentation. I'm compelled by your statement that music can be as powerful a narrative tool as maps for telling the story of ecological change over space and time. Could you speak more to the storytelling potential of sonifying rather than only visualizing ecological data?
Sure, I'm going to answer quickly, and probably Matthew has a lot of wisdom to share in there too.
Yes, please do, Matthew.
The interesting part between, say, a video of an animation of a map, or as we have seen, imagine the slowing the curve of COVID in 2D, is that with data sonification, we can generate emotions. We can say, or we can almost anticipate what's next. If we find certain patterns in our ears, we can say, okay, we're going up. That must mean maybe that the bird is going up a thermal, and or I have a heads up that it's going to go down. So the interpretation of music allows us to disentangle, in my subjective view, much more complex patterns in a very interesting way. And
yeah, so the interesting thing about sound in general is that you can hear something once and then not hear it again for quite a number of years, decades even, hear it again and you're back in the same place and time that you were before. So we have a remarkable memory for tone color. So there's that, where our visual memories are unreliable. And I once had a fascinating conversation with a detective in New York. He said if someone describes a crime entirely in visual terms, there's something wrong with their story. If they do not mention smell or sound, something serious is missing. So it's an interesting thing. The other thing about sound that is remarkable is that you can layer sound. You can have multiple layers together and it will make sense. I mean, that's literally the meaning of harmony. So there, I think in terms of sonification and sort of representing multiple layers of data, then there's tremendous potential there. So the way that our brains work, for example, is if you have multiple people speaking at the same time, we have difficulty passing language. But if you have multiple instrumentalists playing at the same time, well, we love that. So there's tremendous potential, and I think bringing the two together. So how does the visualization and sonification work together? And another thing that I didn't mention, when I work with the raw data, whether it's playing around with the termites and I've worked with Marcel Dietrich at the School of Medicine. He is a neuroscientist and is in comparative medicine, looking at, this is a little distressing, crying baby mice, and then mapping that onto musical parameters. There's something authentic about the data because it's producing sounds and shapes that I would not have done on my own as a composer. So I'm hearing things anew, and I think people possibly recognize that. Even that sort of initial experimentation with the pigeons, there's something's going on there. And I think I think that's what we're trying to get at. It's like, can you actually tell a difference between these species? Whether in terms of what we're doing, it's just we're making decisions in terms of the sounds we're using, but we're not choosing the notes or the rhythms. So I think there's a really interesting experiment to be done there. But I think the most important thing is our memory of placing sounds in time and place. And if you're looking at the loss of the sound worlds, and this is the work of Bernie Krause, and he's been doing these recordings for years and years and years. And when you layer them up over decades, it's remarkable. I mean, of course, it's deeply distressing. So I think this is one way to kind of get at that and making it clear to the public. So that's a wonderful question. Thank you, Megan.
Thank you. Okay, from our next participant, another commendation, wonderful work. A question about tracking insects, especially regarding the ants and termite work. How would you track insects in their natural environment as opposed to petri dishes? I was wondering the same thing. And the participant says, thinking especially about bees. Different sounds, different relation?
Yeah, there about the tracking through computer vision, there I have to give a shout out to my alma mater and past employer, the Max Planck Institute for Animal Behavior, and the newly formed Center for the Study of Advanced Collective. Work from Ian Cousin and his group has been pioneering computer vision and tracking of freely animals. I would recommend reading papers. There's a computer vision package called Tractor. There's a computer vision package called T-Rex from Tristan Walter and Ian Cousin, eLife 2018, I think. And then there's also a paper in a Python package called Deep Post Kit from Blair Costello, Ian Cousin, and a few other people. So I would start by getting a very clear background. I'm not an insects person at all. I work with ginormous tortoises that move very slow and live forever. That's why I have it easy in my research. But those were places I would explore with Center for the Advanced Study of Animal Collective. They probably have a couple answers. They're working with ants building bridges and how the collective helps shape these structures that are bionic in time. They work with social networks of bees. That would be a good starting point.
Thank you. Next question. Do animals change their behavior from the sound they generate using your code? It would be cool to know whether they move to make sounds they like or enjoy. So working on a feedback there. And again, cheers for an amazing presentation.
That's a really good question. I'm not 100% sure I understand it, but so there's a lot of research looking at playback experiments to see, for example, how would a zebra react if it hears a lion? So that sort of research has been done extensively, also to look at how plastic animal responses are. Whether or not animals like certain music, I am not sure. I'm sure there's a lot of psychological research into whether dogs like classical music or not. I would have to see. That's a really good question. I might try it out with my neighbor's dog.
Okay. What music software was used to map the termite music? Logic, Mainstream, GarageBand, etc.
We used Ableton. And in its simplest form, the video that you see there was GarageBand, where we literally just dragged almost randomly instruments to see if it sounded, and it sounded beautiful. But most of the more complex patterns that Matthew is using is from a software Ableton.
Okay, and a follow-up question from the same participant. And for the termites, was pitch mostly determined by position of the termites? If so, how were other parts of the music, like volume, determined? Matthew, and you want to interject too?
Sorry, where's this? Which question is this?
Sorry, Aaron's question here. Was pitch mostly determined by position of the termites? And if so, how were other parts of the music, like volume, determined?
Yeah, so I think in the case of the termites, it was mostly coordinate position. and some of the way in which the music software interacts with that is also producing nuance, which is, accents and dynamic variation. So that's not, in that case, that's not really coming directly from from the termites. I mean, it could, because we have enough data to map that onto it.
In one of the videos, though, the one where you see the Petri dish and the musical instruments, there, shout out to John Koss, who's an electric engineer helping with this project. We actually were able to map chord progressions based on the collective state of the system. So if at a given time point, say our Excel sheet says these 8 termites are in polarized state, it would play different chords than if 20 rows later, all the termites are like far away from each other. That would be a transition state. So we're actually able to, as Matthew said, the pitch is determined by the position, but also some of the chords are determined by the collective state of the system, which is really interesting because we're playing with the group and the individual. So you could almost think in future work, someone making the background noise and a single pigeon or an individual playing the melody.
Yeah, I mean, there's a little bit of some kind of accidental discovery. So from when the animals move from position to position, the velocity of that movement can produce really interesting musical results, which are surprising to us. So that's not programmed in directly. That's coming from the interaction between the data and the musical software. So it's a gift, happy accidents. But the next step, for example, is to look at, say, velocity and position to not only control pitch, but to control spectral information. So in any musical sound, there's going to be harmonic content, and that harmonic content will change over time. That produces a nuance and shape and a single musical note, for example. So I think there's something potential. There's a lot of potential there when you're looking at, say, the memoration of stylings, where you get these sort of darker shapes and shading and things like that. I mean, there's so many animals, it wouldn't make sense to map them all onto a single pitch, but you could control like the filtering of it. So we're also getting into psychoacoustics here. So there's a kind of a psychological testing element to this, which is potentially really exciting too. So going back to the original question, like what does sonification offer, and it does have this sort of psychological dimension too, which is I think it has a lot of potential.
Indeed. Okay, we have many questions, as it's a measure of how engaged the audience is with your wonderful presentation. Beth asks, what, if any, impact do the sounds made by the animals have when sonifying their movement? Do you ever integrate their natural sounds with the instrumental sounds? And if so, is it harmonic?
We have started to experiment with that, and so we have these wonderful. I had an audio moth in my backyard, just sitting there for a month, and yes, it records every 20 minutes. So we have like absolutely enormous amounts of these recordings, and I mean it really does work just to play the recording up using, say, the Merlin app from the Cornell Ornithology Lab, and it will identify it. So the idea is to create ambient backgrounds that are essentially filtered, filtering out I-95, which is also not too far away from my house, and you can create rather wonderful shifting musical textures, and the idea is that we would put those behind the more frenetic tracking data. So that's I'm really glad that someone had that observation. That's good thought.
Yeah, that's, as Matthew said, that's a great point. And I'm working on a song called Glitch Crab, where I want to map some melodies made by crabs using computer vision, but also the sound they make when they close their whatever this is called. So stay tuned; it will come to my SoundCloud.
Yeah, and please share it with us. We'll post it. Okay, an evocative question from Stephen. Some giant tortoises still alive today were also alive when Beethoven went deaf. How do we tell the story of a 200-year-old life through music? Can we bring the living tortoise and dead Beethoven together?
I think Matthew might answer this question, as he has been working on an opera with people who were...
Oh, yes. So I'm working on an opera about Alan Turing, and we've trained it. The libretto is written by an AI. We're using GPT-2 and GPT-3, and we've trained it only on Turing's published papers and also books that we knew that he had read as a child. And then you ask the AI, can computers think, can machines think, and you get these rather extraordinary answers. So I think there's possibly potential to use artificial intelligence for predictive sound making, and we have done some experiments with that. You can use these same algorithms can be used for images as well. So it's not GPT-2 or GPT-3 are a natural language model. So primarily they're there for language construction, but you can use them for sound and image as well. So yeah. So that's kind of a holy grail, but sure.
Something to aspire to.
Yeah.
From Richard, what about tracking radiant shifts in internal parameters such as temperature, electrical activity, etc.?
That's a great idea. And one of my PhD chapters is actually to see whether animals can predict weather. And I think anyone who has seen a bird flying knows where thermals are. So that's a really good idea. We have increasingly good ability to track the physiology of animals in the wild. And we have mechanistic models that are based on energy expenditure of animals that allow us to, we could build on these theories and create these principles, just like how we have created the principles of collective behavior, and translate those to physiology. I'm kind of improvising here, but if a mice eats something, you could look at its heart rate, or you could look at its caloric intake and play around with that. And maybe the sound of cake eaten by a mice sounds different than a carrot. I don't know.
That was Richard Prum's suggestion, actually, when he came to visit, when he visited the exhibition and the performance at Sci City, and he thought that would be a way of tracking, say, certainly like starlings and things, and these sort of mass demonstrations that you see in nature. So that's a great suggestion.
Great. One more question before we wrap up. Let's see. It says, the participant asks, I was wondering if you have thought about how to interact with indigenous, non-scientific, non-Western interpretations of animal movements and sounds. Indigenous groups throughout the world have local, alternative ways of interpreting animal sounds and movements. For example, the songs of certain birds mean certain things for a particular indigenous group. And certain communities have a history of imitating and incorporating animal sounds into their own musical practices and movement practices. So how have these modes of listening and mapping sound, how could they be put in conversation with your own projects? Very insightful question.
Oh, I love that question. Thank you so much for bringing that up. And as someone who's from the Global South, this is incredibly important to me personally on every single level, including my science. And as an example, the country I'm from, Uruguay, actually means river of the painted birds. Gua means coming off, E means water, and Uru could mean zone off, or a type of bird. So everything in our language, our reality, names of places have a variety of different meaning depending on different culture, different spiritual practices. So I'm incredibly excited of when I go to home this year in South America and travel a little bit more. It's been hard with the COVID-19 pandemic to learn more and listen how different animals have been perceived through culture, especially as we start thinking about, for example, in the United States, land back movements and how this relates to the cultural heritage of people. This is a great question.
No, it's a fantastic question. So composed an opera a number of years ago about the meeting of the Europeans with Māori in New Zealand. So when Captain Cook first came, and I collaborated with a Māori musician who was playing a variety of instruments, and she was a trained musician, but it wasn't a useful conversation to sort of approach it from a Western perspective. So the most valuable thing to do is to talk about the story and the place and the material and the purpose of the instruments that she was using, and then through that essentially kind of dramaturgical conversation, we were able to find a place for that in the music. So I think that the most important step, of course, is the nature of the conversation and figuring out how to communicate. So it's a wonderful question, and I would absolutely want to investigate that, and the Māori name for New Zealand, Aotearoa, means land of the long white cloud. So if we can talk about origin names, yeah.
Anyway, let me take this moment to once again thank you both, Diego and Matthew, for an absolutely wonderful journey. What an exciting, inspiring project. And I think that, the prospect of conveying the urgency of climate change, the loss in biodiversity, if sonification can emotionally compel people to believing it and springing into action, gosh, we would be living in a very different world. So collectively, this was absolutely thrilling. We wish you very well. Please keep us posted with the work. And thank you so much, Ty, for helping set up the event, and to Guy for a recording and making this all happen. And Ty, also, thanks for handling these wonderful questions. Thanks to the audience for engaging so deeply and asking such meaningful questions. So before I draw the event to a close, I just want to mention that we have one other Frankie Fellow to close out this season this academic year, Dr. Anna Florence, a former Frankie Fellow as well, who has gotten a faculty position at Columbia, and she'll be talking to us about social and structural contours of marginalization in the context of COVID-19, talking about her work with marginalized groups. So once again, thank you very much, and bye everyone. And Matthew and Diego, this project is just absolutely thrilling. I hope you get a chance to share it with many, many more people. We'd be happy to advertise what you're doing on our website. And Matthew, please do invite us to your opera when it's done.
Sure.
Yeah. And I think what is very exciting for me as well was a recent Nobel Prize in Physics went to Giorgio Parisi, who actually worked out the collective phenomena, the description, the language to describe the motion of starlings, for example, which is the same kind of formalism that you would have to describe the collective behavior of atoms. So it's the same underlying framework that transcends. So your work is inspiring very similarly with the kinds of applications. Thank you.